In this video, we'll be tackling proportional reasoning problems. So let's start off with question 1. A cart of mass m moves with speed v and has kinetic energy k. If the speed of the cart is tripled, what happens to the kinetic energy? So the formula that we're going to use this problem is k is equal to 1/2 mv squared. And the proportional form of this equation is k is proportional to mv squared. And this is because the constants just cancel out. So you would ignore 1/2. As this quantity gets larger, the 1/2 becomes essentially insignificant. So that's why you don't really need it when you're dealing with the proportional relationship. So the change is that the speed is going to be tripled. So that means that v goes from that to 3v. So then you apply the square. So then k is going to be proportional to 3v squared is equal to 9v squared. And this is 9 times the original. So that means that k prime is 9 times the original. So yes, that's going to be 9k. Now let's move on to our next question. Question about gravitational force change. So the concept is that gravity is an inverse square law, so the distance matters a lot. So that is quite important and will scale up quite a bit. So we have the formula Fg is equal to g m times m divided by r squared. Fg is gravitational force, g is the constant of gravity, m and small m are masses, and r is the distance between the center of the masses. And the proportional form of this is just Fg is proportional to 1 over r squared. Because these are constants, which will be things that you will plug in, so they don't really matter. Might as well just make that in red. And the change is going to be r to 2r, so then you apply the inverse square. You have f is equal to f times 1 over 2 squared. So that's going to equal to f over 4. So essentially what you're doing is you just kind of plug in 2 for r. And you just solve. So let's do 3. So the formula you're going to use is u is equal to mgh for this. Now, let's read the question. An object of mass m is raised to height h above the ground and has a gravitational potential energy u. If the height is halved, what happens to the gravitational potential energy? So you use u is equal to mgh, where u is gravitational potential energy, m is mass, g is gravitational field strength, approximately constant near Earth. And this is gravitational field strength. And the proportional relationship that you'll use is u is h, because these, again, they're constants and they don't really affect in the long term. So h is going to be halved. So now it's just going to be a linear relationship where it's going to be halved. So the answer for this is C. Now we have a question about spring potential energy. A spring is compressed a distance x and stores elastic potential energy u. If the compression distance is tripled, what happens to the energy stored in the spring? So a concept that you need to know is that springs store energy like kinetic energy, and distance is squared, so small increases will give a big. So because it's squared, a small increase in compression will result in a big energy increase, and we can see this in the formula that is used to represent spring potential energy, which is us is equal to 1/2 kx squared, where us is elastic potential energy, k is a spring constant, which is essentially the stiffness, and x is compression / stretch distance. So the proportional form of this is US is proportional to x squared. So these cancel, and you change x to 3x, and then you apply the square. So you have US is proportional to 3x squared. That's equal to 9x squared. And that's 9 times the original. So you have